We're going to start a new unit, and this is going to be on something called energy. I'm going to look at two different types of energy, and then we're going to just look at how energy goes from one of those forms to the other. But before we look at the specifics of energy, just a basic definition: energy is the ability to make something happen. So think about it this way: when you're really tired, you have no energy, you have no will to want to do anything or make something happen. Same kind of idea when it comes to physics. An object needs to have energy in order for something to be able to happen. So we're going to look at two types of energy. The first is gravitational potential energy, and this is energy stored due to an object's height above a base level. So what do I mean by that? The base level is something that you set. Let's say we're looking at a table on the floor and there's a ball on the table. If you set your base level as the table, then there is no gravitational potential energy, because it can't fall anywhere if you're looking at the table as the lowermost point. However, if you set the floor as your base level, then it has gravitational potential energy. So the base level is arbitrary. It depends on where you want to set it, and it depends on the problem where it's going to make most sense to set that. I tend to look for wherever the object is the lowest, that becomes your base level. The symbol for gravitational potential energy, we're going to call that GPE. So it's just the first three letters of the three words, gravitational potential energy. The unit for energy is a joule, and I'll define that in a little bit, but it's a capital J. In the gravitational potential energy equation, GPE equals mass times little g times height. So m is the mass in kilograms, g is 9.8 meters per second squared, and h is the height above the base level. You will always use 9.8 for this g. That won't change because all of these problems we'll be dealing with on Earth. The second type of energy we have is kinetic energy, and that is energy stored in an object's motion. So anything moving has kinetic energy. Symbol for kinetic energy is just Ke, the first two letters of the two words. And because it's energy, the unit once again is joule, capital J. Equation for kinetic energy is 1/2 mv squared. V is the speed in meters per second. M is the mass in kilograms. 1/2 is just a constant. And then the unit for energy is a joule. So this is the unit of energy. 1 joule is equal to 1 Newton times a meter. So when you're looking at the units, especially if you're dealing with a lab, a joule can be broken apart into a Newton times a meter. And that'll be, like I said, more relevant when we do labs. So I'll do two examples, one using each of the two equations. We have a 54 kilogram student running down the halls with 1760 joules of energy stored in her motion. What is her speed? So because she's running, she's not changing height, and it tells you energy is stored in the motion, we know that the kinetic energy is equal to 1760 joules. 54 kilograms. Kilogram is the unit for mass. So mass equals 54 kilograms. And it doesn't give us anything else. Equation for kinetic energy, Ke equals 1/2 mv squared. So 1760 joules equals 1/2 of 54 kilograms times v squared. Half of 54 is 28. Nope, it is not 28, it is 27. So 1760 joules equals 27 kilograms times v squared. Divide both sides by 27 kilograms. We get did the wrong thing in my calculator. 65.19, and this would be meters squared per second squared. That's speed squared. Take the square root of both sides. 8.07 meters per second. That's really fast to be running down the hall with. But that would be the answer. Okay, so now for number 2, you have a 0.350 kilogram bottle of Gatorade sitting on top of the bleachers. It tells you there are 24 joules of gravitational potential energy, and we want to know how high the bleachers are. So the Gatorade bottle is on top of the bleachers. It's going to make sense to set the ground as the base level, because it tells you that there is gravitational potential energy, so that Gatorade has the potential to fall. You know that the mass, it's given in kilograms, is 0.35 kilograms. The gravitational potential energy is 24 joules, and we're looking for the height of the bleachers. Gravitational potential energy equals mgh, 24 joules equals 0.35 kilograms times 9.8 meters per second squared times your height. 0.35 times 9.8 is 3.43. So 24 joules equals 3.43. And this would be newtons, kilogram meters per second squared, times the height. Fun fact while I'm here, mg is fg. So fg equals mg, that is in this equation. 24 divided by 3.43. 6.997 meters equals the height. So height is about equal to 7 meters. Now, where did those meters come from? I divide both sides by 3.43 newtons. The units are joules over newtons. Earlier, I told you a joule was a newton times a meter. Divided by newtons, the newtons cancel, so that's where that unit of meter came from. We're not going to do too much just straight up calculating the types of energy. The bulk of what we're going to do is going to be to look at gravitational to kinetic or kinetic to gravitational. So looking at one form of energy to another, but I just wanted you to kind of get used to using the equations to see how they work, and just being careful with being able to plug in numbers and solve. But those are our two types of energy: gravitational potential and kinetic. Like I said, gravitational potential is arbitrary. It depends on where you set your base level for. Kinetic energy, as long as something is moving, it will have kinetic energy.